It is acceptable to run a 110 volts power cable and a low voltage signal cable in the same conduit, but specific requirements must be met to ensure the safety and functionality of the installation. Firstly, the conduit must be large enough to accommodate both cables without overcrowding. Use a conduit with a cross-sectional area that is at least 40% greater than the combined cross-sectional area of the cables. Secondly, the cables should be separated from each other within the conduit. This can be achieved using cable ties or spacers. Thirdly, the 110 volts power cable and the low voltage signal cable must be electrically isolated from each other. This can be done by using different types of cables, for example, armored cables for power and shielded cables for signal, or by using a cable separator. Fourthly, the conduit should be routed in a way that minimizes electromagnetic interference from the power cable to the signal cable. Keep the cables as far apart as possible within the conduit. Fifthly, the power cable must be properly grounded in accordance with electrical codes. The signal cable should also be grounded at the source and destination. Sixthly, label the conduit and cables to clearly indicate the contents and voltage levels. Seventhly, follow all applicable electrical codes and standards for the installation of power and signal cables in the same raceway. Use high-quality cables that are rated for the voltage and current levels involved. Make sure the cables are properly terminated at both ends. Test the system to verify proper operation and ensure there is no electromagnetic interference. It is important to always consult with a qualified electrician or electrical engineer to ensure that the installation meets all applicable codes and standards. The National Electrical Code, or NEC, provides detailed guidelines for electrical installations, including those involving both power and signal cables. Some key NEC articles to consider are Article 300.3, which covers conductors of different systems. This section addresses the installation of conductors for different voltage systems within the same enclosure, raceway, or cable. It specifies conditions under which this is permitted and outlines requirements for insulation voltage ratings. Article 300.11 covers securing and supporting wiring. This article details how wiring and cables must be securely supported to ensure they do not sag or become damaged over time. It includes requirements for using appropriate supports and fasteners. Article 310.15 addresses ampacity of conductors. This section provides guidelines for determining the allowable ampacity, or current carrying capacity, of conductors based on factors such as conductor size, insulation type, and ambient temperature. It includes tables and formulas for calculating ampacity under various conditions. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. This article provides requirements for low-voltage circuits used for control, signaling, and power-limiting purposes. It includes specifications for wiring methods, overcurrent protection, and insulation. Article 800 addresses communications circuits. This article covers the installation of communication cables, including telephone, data, and network cables. It includes requirements for separation from power conductors, grounding, and protection against lightning and other electrical hazards. Furthermore, regarding conduit fill, the NEC specifies the maximum allowable percentage of the cross-sectional area of a conduit that can be occupied by conductors. This is to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation. Chapter 9, Table 1 provides the percentages of conduit fill permitted. Generally, the maximum fill is 40% for 3 or more conductors. When dealing with both power and low voltage cables in the same conduit, it is crucial to adhere to these fill requirements to prevent overheating and ensure the integrity of the wiring. Additionally, ensure proper separation and insulation between power and low voltage cables within the conduit to minimize the risk of interference and electrical hazards. When running both power and low voltage cables in the same conduit, maintaining proper separation is crucial to prevent interference and ensure safety. Insulating the power cable is a primary method for preventing electrical hazards. Ensure that the power cable has adequate insulation suitable for its voltage rating. Use cables with high-quality insulation materials that meet or exceed the required standards. Physical separation can be achieved by using barriers or dividers within the conduit to keep the power and low-voltage cables apart. This helps to minimize the risk of direct contact and interference. Shielded cables for the low-voltage circuits can provide an additional layer of protection against electromagnetic interference from the power cables. Grounding is another essential aspect of electrical safety. Properly grounding both the power and low-voltage systems helps to minimize the risk of electric shock and provides a path for fault currents to flow safely back to the source. Ground the metal conduit itself to provide an additional layer of protection. Use appropriate grounding connectors and ensure that all connections are secure and comply with electrical codes. Regularly inspect the installation to identify and address any potential issues, such as damaged insulation, loose connections, or signs of wear and tear. Perform periodic testing of the grounding system to ensure its effectiveness. Keep detailed records of all inspections, testing, and maintenance activities. Document any repairs or modifications made to the electrical system. Cable ties and spacers can be used to maintain separation between the power and low voltage cables within the conduit. Choose cable ties and spacers that are made of non-conductive materials to prevent electrical conductivity between the cables. Secure the cables at regular intervals along the length of the conduit to prevent them from shifting or coming into contact with each other. Follow manufacturer's recommendations for installation and spacing of cable ties and spacers. Different types of cables have different insulation properties and voltage ratings. Armored cables, such as AC or MC cable, provide a high level of protection for power circuits due to their metallic sheathing. Shielded cables, such as twisted pair or coaxial cable, are designed to minimize electromagnetic interference in sensitive electronic circuits. Fiber optic cables are immune to electromagnetic interference and are suitable for data transmission in electrically noisy environments. When selecting cables, consider the specific requirements of the application, including voltage, current, environmental conditions, and susceptibility to interference. Consult with a qualified electrician or electrical engineer to ensure that the selected cables are appropriate for the intended use. In summary, safely running power and low voltage cables in the same conduit requires careful planning, proper installation techniques, and adherence to electrical codes and standards. By following these guidelines and consulting with qualified professionals, it is possible to minimize the risk of electrical hazards and ensure the reliable operation of electrical systems. Remember to always prioritize safety and consult with experienced professionals when working with electrical installations. Failure to follow proper procedures can result in serious injury, property damage, or even death. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. Proper grounding is a critical aspect of electrical safety, especially when running both power and low voltage cables in the same conduit. Grounding ensures that any fault currents are safely diverted back to the source, minimizing the risk of electric shock and preventing damage to equipment. The power cable must be properly grounded in accordance with electrical codes, typically by connecting the grounding conductor to the grounding busbar in the electrical panel. The signal cable should also be grounded at both the source and destination to minimize noise and interference. Use appropriate grounding connectors and ensure that all connections are secure and comply with electrical codes. The metal conduit itself should also be grounded to provide an additional layer of protection. Regularly inspect the grounding system to ensure its effectiveness and integrity. Properly labeling the conduit and cables is essential for identifying the contents and voltage levels. This helps prevent accidental contact with live wires and ensures that maintenance and repair work can be performed safely. Use durable labels that are resistant to fading and wear. Clearly indicate the voltage levels of the power cables, such as 110 volts or 240 volts. Label the signal cables with their function, such as data or control. Use different colors for labels to distinguish between power and signal cables. Place labels at regular intervals along the length of the conduit and at all access points. Ensure that the labels are easily visible and legible. Labeling helps to prevent confusion and ensures that electrical work can be performed safely and efficiently. Follow all applicable electrical codes and standards for the installation of power and signal cables in the same raceway. These codes and standards are designed to ensure the safety and reliability of electrical installations. The National Electrical Code, or NEC, is the most widely used electrical code in the United States. State and local codes may also apply, so it is important to check with local authorities. Ensure that all work is performed by qualified and licensed electricians who are familiar with the applicable codes and standards. Obtain any necessary permits before starting work. Failure to follow electrical codes and standards can result in fines, penalties, and safety hazards. Always prioritize safety and consult with qualified professionals when working with electrical installations. It is always best practice to test the system after installation to verify proper operation and ensure there is no electromagnetic interference. Use a multimeter to measure voltage levels and continuity. Check for any signs of overheating or unusual noise. Verify that all grounding connections are secure. Use a signal generator and oscilloscope to check for electromagnetic interference on the signal cables. Perform a load test to ensure that the power cables can handle the expected current. Document all test results and keep them on file. If any problems are found, correct them before putting the system into service. Testing helps to ensure that the system is safe, reliable, and performs as expected. Use high-quality cables that are rated for the voltage and current levels involved. Cheap or substandard cables may not meet safety standards and could pose a fire hazard. Choose cables that are UL listed or otherwise certified by a recognized testing laboratory. Ensure that the cables are sized appropriately for the current they will be carrying. Use cables with adequate insulation to prevent shorts and ground faults. Consider using shielded cables to minimize electromagnetic interference. Select cables that are resistant to moisture, chemicals, and abrasion. High-quality cables are more durable, reliable, and safe than cheap cables. Make sure the cables are properly terminated at both ends. Loose or poorly terminated connections can cause voltage drops, overheating, and arcing. Use appropriate connectors and tools for the type of cable being used. Ensure that all connections are clean and tight. Follow manufacturer's instructions for terminating cables. Properly terminated cables are essential for ensuring a reliable and safe electrical connection. Consider the environmental conditions when selecting cables and conduit. In wet or corrosive environments, use cables and conduit that are specifically designed for those conditions. Use watertight fittings and seals to prevent moisture from entering the conduit. Protect cables from physical damage by using conduit or other protective measures. Consider the temperature range of the environment and select cables that are rated for those temperatures. Harsh environmental conditions can degrade cables and conduit over time, so it is important to choose materials that are durable and resistant to those conditions.